Okay, so in this video we're going to go over more concept. We're going to use a question that came in 2020 paper 2. That was question B3. Alright, so that's section B of the paper 2 science paper, which is chemistry. Alright, so the statement says, in an experiment to prepare a salt, a learner reacted 3.0 grams of magnesium oxide with 40.0 centimeter cubic of dilute nitric acid of concentration 2.0 mole per decimeter cubic. So that's what we are given right there. So please just don't mind this part. Yeah, so we cancel that part. Alright, so the first question is asking us to write a balanced chemical equation. So in this case, if I were to write the word equation first, okay, say solutions down here. Right, so if it would be very easy for us to take the approach of first writing the word equation. So what we have is that we are reacting magnesium oxide, okay, magnesium oxide plus what, plus dilute nitric acid. That's the formula for nitric acid right there, NHO3. All right, to get what, what we are going to get is a salt, which is magnesium nitrate. Okay, so we get magnesium nitrate with a 2 out there, plus what, plus water. Okay, so what we need to keep in mind is that as we write in this manner, we should keep in mind to say, let's say we know to say the valence for magnesium is what, is 2, for oxygen is 2, hence these are just cancelling each other. It's more like you have to exchange, then they cancel each other. Then for nitric acid, for nitric acid, what we have here is what, is a 1, and for a nitrate, that is NO3, what we have is a what, is a 1. Hence when you bring in together magnesium, what, magnesium has a 2, then nitric a nitrate has what, has a 1, then these two are going to interchange, hence that's why we have the 2 that we have down here. Okay, so this is aqueous. That's aqueous right there, that's the liquid right there. Okay, so that's the balanced chemical equation that we have. We need to keep in mind to say from the weight equation is what, is magnesium oxide, okay, plus what, plus nitric acid there, giving us what, magnesium nitrate. Okay, we get magnesium nitrate, plus what, plus water. Okay, that's what we get. So that's the balanced chemical equation that we are being asked to do what, to write this one right here. Okay, so now the next question is asking us to calculate the number of moles of what, magnesium oxide, as well as what, as well as dilute nitric acid. So here is how we go about it. We know to say number of moles is equals to what, is equals to our mass divided by what, our molar mass. And in this case, we want to find the number of moles of what, the number of moles of magnesium oxide. All right, so we need to clearly indicate to say we're calculating the number of moles of what, magnesium oxide here, which equals to what, the mass of what, the mass of magnesium oxide divided by what, the relative molecular mass of what, magnesium oxide again here. That's what we're going to have. So what do we have? The question has given us to say the mass that we have for magnesium oxide is 3.0 grams. So it's very important that here we write what? We also write the units that we have. We have 3.0 grams of what? Magnesium oxide. So we need our relative molecular mass there. We know to say what we have is magnesium right here, and we have our oxygen. So we know to say our oxygen is 16. We know that our what? Our magnesium is what? 24. Okay, the mass for magnesium on the when you go to your periodic table is what? Is 24. So we need, when we add this together, what you're going to get is what? Is 40. 40. Remember to say this 40 is in what? In grams per what? Per mole. Right. So basically we just put what? We put our 40 grams per mole right here. Okay. So we are going to divide 3.0 divided by 40. What you're going to get is what? 0.075 0.075 moles. Okay, so now the question is, how do we, why was it necessary for us to write what? For us to write the units here. Remember to say we are saying we are dividing this gram for the mass, divide by what? The gram per mole of what? Of this same magnesium oxide. So here you are going to put grams multiplied by, these are going to interchange, you're going to have moles on top, divide by what? Divide by grams right there. The grams goes, remain with more. So that's how we come about having that unit of mole right there. So it's very important, as in whatever question that you're dealing with, write all the units, whether you're multiplying or dividing, whatever components that you're going to be given. Okay, so that's the number of moles for what? For magnesium oxide. So remember to say Elena is reacting 3.0 grams of magnesium oxide with 40.0 centimeter cubic of dilute nitric acid of concentration 2 mole per decimeter. So now, for us to find the number of moles of what? The number of moles of dilute nitric acid is that we need to remember that we can also calculate the number of moles using what? Concentration as well as the volume that we are given. So we can say concentration we denote using what? We denote it using M, say from molarity, is equals to what? The number of moles, or just say moles here, divide by what? Divide by the volume here. Okay, so basically for us to find the number of moles, we just say number of moles is equals to what? Just the concentration multiplied by what? The volume that we have. So here we are saying the number of moles of what? Nitric acid. Nitric acid is equals to the concentration that we have been given is what? We have been given 2.0 mole per what? Per decimeter cubic. We are multiplying it by what? By the volume. The volume that we have been given is 40 centimeter cubic. 40.0 centimeter cubic. So keep in mind to say what we have here as our concentration is in mole per decimeter cubic, and what we have as our volume, I mean, is what? 40 is 40.0 centimeter cubic. So we want to make sure to say we have the same units right here, so that we get the required value that we need to get, because we are not able to cancel the centimeter and the decimeter right there. So we have to convert this 40.0 centimeter cubic to what? To decimeters. So here is how you can go about it. The easiest way how you can go about it is this. So we have our 40.0 centimeter cubic. I'll say divide by what? 1. I'll multiply here. So I'll convert this. We'll take it step by step, but of course there is a direct way of going about that, just there from centimeter cubic to decimeter cubic. But let's try to take the route of taking it to meters cubic first before we take it to what? Decimeters. Okay, so here I should make sure to say what I'm cancelling. Let's say I have my centimeter cubic on the numerator. It should be on what? the denominator here, meaning I have what? My centimeter here. So I just have to remember to say 1 meter cubic is equals to what? 10 to the power what? 10 to the power 6 centimeter cubic. Maybe someone would not understand how that has come about. We say 1 meter is equals to what? 100 centimeters. What about 1 meter cubic? Meaning I'm multiplying this, multiplied by what? I'm multiplying it by what? 3 times. Okay, so we are saying 100 times 100 times 100. You're going to get what? That's what we're going to get right there. That is 1 million, something like that. So hence we just write it as what? 10 to the power what? 6. When you go to a calculator, you punch 10 to the power 6 is to give you what? A 1 with what? 6 zeros. Or maybe you can just write 1 exponential what? Exponential 6, which is still the same thing. Alright, just different in terms of how you put it. Alright, so meaning here we are converting just at this point. You are able to convert what? From centimeter to from centimeters to what? To meters. So here it's more like the centimeter cubic is going to cancel, and the centimeter cubic is also going to cancel on the denominator there. But I still need to present my decimeters. So I just have to know to say how many meters make up whatever decimeters that I want to get. So meaning my meters are going to be down here. So I need to keep in mind to say, let's say 1 meter cubic. I ask myself how many decimeter cubic are in 1 meter cubic. So what you need to keep in mind as well is that 1 meter is equals to what? Is equals to 10 decimeter what? Is equals to 10 decimeters. Meaning 1 meter cubic is equals to what? 1000 what? 1000 decimeter what? Decimeter cubic. So that's what we have right here. So we have our what? Our 1000 dm to the power 3. Right. So now here's where it gets interesting. So meaning these meters are going to go, and these meters are going to do what? To go. This centimeter cubic are going to go, and these centimeters are going to go. Hence remain with our dm right there. So we have to multiply 40 multiplied by 1000 divided by 1 million. Okay, so you say 40 multiplied by 1000, we are going to get 40,000 here. Okay, so you are saying 40,000 divided by what? I'll try to attempt to write all the zeros to make it simple here. So meaning this is 1 million that we have right here. Okay, this goes, that goes, that goes, that goes. This is the simplest method that you can use. That goes and that goes as well. This goes and that goes. So meaning you are saying 4 divided by what? 100. You are getting 0.04. Even if you say 40,000, okay, 40,000 divided by what? Divide by 1 million. Yes, direct on the calculator is still going to get what? 0.004 what? Decimeter cubic. So that's what we are looking for right there, because we want our volume to be in what? In decimeters as well, right? So it's very important when it comes to converting. Just take it step by step. You're going to find that it's very interesting, and you're going to arrive at the answer that you're looking for. So we have our what? 0.04 what? Decimeter what? Cubic. So what we have right here is, you say 0.04 multiplied by 2. What we get? We get what? 0.080 moles. How does this moles unit again brings about itself? We have our mole here for what? For volume. Mole divided by what? Decimeter cubic. This one right here is the one that is at this point. It's just slash, meaning over. Again, we are multiplying it by what? We are multiplying it by a decimeter cubic, meaning this decimeter is going to cancel and that decimeter is going to cancel, meaning we remain with what? With moles. But let's say if we didn't convert our volume, we say mole over what? Decimeter cubic over the concentration multiplied by what? Centimeter cubic. You can't cancel centimeter cubic and decimeter cubic because they are not the same, unless if they were of the same value. Let's say we say 1 decimeter cubic is equals to 1 centimeter cubic, then that would make sense. So those are the moles of what? Nitric acid. So the last question now is asking us to determine the limiting reagent. So what do we mean by the limiting reagent? when, let's say you are reacting reactant A plus what? Plus B to get what? To get product C plus what? Plus D. When these two are reacting, A and B, you find that one of them is limiting. What does it mean? It means it's going to be used up completely in that chemical reaction before the chemical reaction is over. Hence, the products depend on what? The products depend on the limiting reagent. That is what it means. It's more like, let's say you had 4 grams of what? A, then you had what? 6 grams of B. Okay, we had 6 grams of B. Then you find that if you try to do some calculations, when you find that these 4 grams of A only needed about 5 grams of what? Of B. So what it basically means is that out of the 6 grams of B that you're going to have, the only ones that are going to react is what? Is 5 grams. Meaning this one you're going to have a remainder of what? Remainder of 1 gram. But what it implies is that the 4 grams is the one that was what? That was limiting, because the whole of 4 grams is used, but the whole of 6 grams is not what? Is not used. And that is what we want to try to do in this case. So we want to find the limiting reagent between what? Between magnesium as well as what? As well as nitric acid. We know which one is going to... Okay, so here it's very important that we get back to our what? Our balanced chemical equation. So when you look at this is just a balanced equation. Of course, looks like we didn't balance it. So we need to, since we have a 2 right here, we need to put what? Another 2 right here. Okay, and we put another 2 right here. No, we just okay like that. We have our oxygen, we have 6, that's 7, we have a 60 side 7, magnesium 1, nitrogen 2, another nitrogen 2, hydrogen 2 right there is balanced. So now what we have here is this. We have our magnesium oxide plus what? Nitric acid. So we have already calculated the moles that we have from the basic formulas that we have for, the basic information that we are given. So when look at what we have here, the mole ratios. So we should keep in mind to see the mole ratios of A is equal to the mole ratio of what? The number of moles of what? The number of moles of B divided by 1 here. So what do I mean by A and B? A and B is magnesium oxide. Our B is what? Dead nitric acid. So in this case, what we have is this. It's not always that it's just going to end at B. It can be C, D, so on and so forth. All right. So we need to compare now the number of moles that we have here and right here. So what we are going to do is that I'm going to pretend I don't know one of the moles here. Let's say I don't know the number of moles of what? The number of moles of nitric acid. Then I know the number of moles of what? The number of moles for magnesium oxide. So the number of moles of magnesium oxide is what? 0.075. Say 0.075. I have 0.075 moles. The mole ratio that I have here is the coefficient of magnesium. What is here? Is what? Is 1. Okay, 1 here is equals to the number of moles of what? The number of moles of nitric acid I don't know, because you're looking for the number of moles that reacted. We are talking about in the balanced chemical equation. Okay, so here we say what? We still maintain the what? We still maintain the NB, which means the B which is representing what? Nitric acid. Then I'll put a 2 here because of the coefficient right there. So here I need to close multiply. So meaning number of moles of B is equals to what? 2 multiplied by what? 2 multiplying by 0.075 moles of what? Magnesium oxide. So you say 2 multiplied by 0.075. What we get? What we are going to get is what? 0.15 moles. So meaning 0.75 moles of magnesium oxide only reacted with the 0.15 moles of what? Moles of nitric acid. And what did we have here? we found to say the number of moles that we have for number of moles that we have for nitric acid is what? 0.08. But this one needed to react with what? 0.18. So it basically means these moles were less than that, and that concludes our say our limiting reagent is what? Nitric acid. So you can use the same method to find you can use a similar method. Instead of using the number of moles, you use the masses. It's still going to give you the same thing. So let's give it a try here. So let's say we find the number of moles of what? The number of moles for, we find the mass for what? The mass for nitric acid. Okay, so we say here the mass for nitric acid, we say mass is equals to what? Number of moles multiplied by what? The relative what? Formula mass. The number of moles that we have is what? 0.08 multiplying by what? The relative formula mass. We know we have hydrogen. We have we say hydrogen is what? When you go to our periodic table, our hydrogen is 1. Okay, our hydrogen, I'll put in bracket, I say 1. Okay, plus nitrogen is what? Nitrogen is 14. Okay, 14 plus oxygen is 16. Then we say 16 multiplied by 3. Multiplied by 3 is what? 48. So we are saying 48 plus 14 plus 1. We get what? 63. So it says 0.08 multiplied by what? 63. So we say 0.08. What do we get? We get what? The mass that we have is 5.0. That. So now when we go to our balanced equation, okay, when you go to a balanced equation, we find that we have magnesium oxide is reacting with what? With 2HNO3. So here we know to say our formula mass for this one is what? 40 grams per what? 40 grams per mole. 40 grams per mole. Okay, what we have here, the mass, let's say I don't know. Okay, let's say I don't know the mass that is there. Then the mass that I have for magnesium is what? I've been given 3 grams. Alright, no necessary x here. Here we have the value of the formula mass. So the formula mass that we found here was what? Was 63. Then we multiply 63 by what? By 2. What are we going to get? 63 multiplied by 2. We're going to get 126. 126 right here. Then here we have our what? We have our 3. So what we don't know is our what? Is our mass. We cross multiply. Hence we say 126 multiplied by 3 divide by what? 40. We get what? 9.45 grams. So we can clearly observe to say this 3.0 grams of magnesium oxide needed 9.45 grams of what? Nitric acid. But nitric acid only had what? 5.04, meaning even using the masses, we're able to see that what? Nitric acid was the one that was what? That was limiting. Yeah. So that's how we go about answering that question. Yeah. Thank you.